All right. Is this thing on? Oh, I see audio levels moving, so it must be there. Good. Let me know if the audio is okay, guys. Welcome everybody to this. It's Thursday. It's time for our Astro Coffee Hangout. I will explain a little bit about this hangout here in just a minute, but first I have good news, everyone. It's 2/20/2020, 02/20/2020. This is amazing for people who like those two digits. This is so rare. This is such a rare occurrence that you have to go back 18 days to have had this before at February 2nd, 2020, 02/02/2020. So this is pretty amazing. Now, the last time this happened was, I think, January 1st in the year 1010, or maybe the year 1100, or the year 11, or the year 110. We could have had, and we're not going to get these kind of digits again until March 3rd, 3030. Just something to think about. Okay, I just want to say all that. So today we're here to talk about Betelgeuse. Now, this hangout is kind of got two formats. Sometimes I can get guests, sometimes I can't. And instead of not doing hangouts on the days when I couldn't get any guests or somebody wasn't available, as you guys may remember from a long time ago, I used to do these every Thursday with guests. But we've had, some key retirements and funding reallocations and things like that, and so now I don't have the same resources I have to get the guests I used to get. So I do still get them. In fact, next week we're going to have a telescope talk hangout on Thursday. I invite you to check that out with the Unistellar folks. They have made the EV scope. I have one sitting over here that I am playing with now. I'm getting ready to make videos on it, and we're going to talk about that next Thursday. So Frank Marchus and Ludovic is his first name, but I forget his last name. He works at Unistellar also, and he's going to be joining me. We're going to talk about the EV scope. So for those of you who are interested in amateur astronomy, you'll want to check that out. So that's right, George. April 4th, 4040 or 4400 or the year 44. We could have. So you get the idea, right? This is amazing stuff. 2/20/2020. I mean, I was this excited back on February 2nd, but I don't know. This is kind of better. 02/20/2020. 02/20/2020 is a great date. So welcome. Hope you guys are having a great 02/20/2020 today. So we are going to talk about Betelgeuse. I've got a lot of people in the chat. The format is also a little bit different than what we're used to. I have a Discord server, and on that Discord server, the link to that is in the description box. On that Discord server is a public voice channel. Link to that is also in the description box. And if you would like to chat with me with your voice, get on the public voice channel. I'll check it out, and I will. If you've got your video and audio or your audio working, I should say, then we'll pipe it in and make it like a call-in show. So that's another way you can interact. Of course, I'm looking at your live chat too. So, I'm seeing Adam Synergy, James Dugan's back, and Peter Q is here as always. So a lot of regulars are here, waiting on Galaxia to show up. She's probably going to be here soon. So I guess you guys have heard the news by now that Betelgeuse is dimming. Okay, so the news came out late last year, early this year, about the star Betelgeuse. And so let's start here. Let me pull up some things. And where did it go? There it is. That's what I was looking for. So here was a story that came out. The European Space Agency came out with this story. I'll get to that in a minute. But for those of you who do not know what Betelgeuse is, let's start with some basics. It is a red supergiant star. It is in the constellation of Orion. And if you can find Orion in the night sky, if your skies are dark enough, then you should be able to see. It's one of the most prominent constellations that are up this time of year. It's up very high in the sky in the southern area, right around 9 o'clock-ish or so. So you'll be able to see it quite well. Anyway, it's this star right here. It's distinctly red in color. You can see the color red. Rigel down here is a blue supergiant. It's also very blue. So you can see these colors. It's really kind of cool. So, you don't need fancy telescopes to go out and enjoy astronomy. Just go out there, look up, and, start enjoying the colors of the night sky. All these stars are very visible. And this star here, Betelgeuse, as I said, it's a red supergiant. Let's look at some of its properties. It's about 700 light years away. Its absolute magnitude is minus 5.85. So that means it's very bright. Okay, you don't have to worry about the magnitude scale because it's very difficult to visualize what those numbers mean, but it's logarithmic, and negative means very bright. It's got a mass of about 11 times that of our sun. It's got a radius almost about 900 times the radius of our sun. So it's big, super giant, as you would expect. It is a big star. It's got a temperature of about 3,500 Kelvin. Red giants are kind of cool, red supergiants. And it's got a rotational velocity of about 5 kilometers per second. And it's, only about 8 or 8.5 million years old. This isn't an old star. Our star is much older than Betelgeuse. So there are some basic characteristics of the star, Betelgeuse. But let's go back to this. So astronomers have been looking at it. And by the way, astronomers have been looking at Betelgeuse, and they have really good photometry that's, since the 1930s. Okay, we've been looking at this star, measuring its brightness, and it has undergone a great many times since then variations in brightness. This one happens to be more pronounced, but because of its age and because of its stage in the life cycle that it's in, we have been studying since the 1930s very precisely its dimming process. And right now, today, it is about 36% less bright than it usually is. And, all of these news articles are saying that you should see that difference, but I'm going to be honest with you. Maybe I don't have calibrated eyeballs, but to me, Betelgeuse still looks pretty good. I mean, I couldn't tell that if I hadn't been reading all these stories, and if I hadn't been, in the loop on a lot of this research, I wouldn't have really noticed just by looking at it. But you tell me. I mean, could you notice a difference? Did you go out one night and go, Betelgeuse, it's dimming. I mean, have you seen it? Have you seen that? Since December of 2018. I mean, so have you seen it? Have you guys noticed any of that? So I haven't. So I couldn't really tell, but apparently it's 30%, 36% is a pretty big dip. So it is I suppose something we should be able to notice if you're paying super close attention. So what are we looking at here? So let me show you this. So here we have Betelgeuse observations. These are from the Sphere instrument from the European Southern Observatory. Now, Sphere, I'll tell you what Sphere is in just a minute. But here's the image on the left is an image taken in January 2019, and then the image on the right is about a year later, in December of that same year, about 12 months later. And yeah, look, it's looking really weird. I mean, that's pretty. This is the surface, by the way. This is the resolved okay, I won't say. Yeah, it is kind of resolved surface taken through the Sphere instrument. Now, Sphere is a really cool instrument that's run on Par and All. Let me just pull that up real quick. Sphere is a lot of buttons to push. Sphere stands for Spectral Polarimetric High Contrast Exoplanet Research Instrument, and as its name suggests, it is designed to look at exoplanets, and it's very sensitive. It uses the transit method to find these exoplanets. And so, wait a minute. No, I'm sorry. It does not use the transit method. It uses direct imaging. It looks at them directly. So it's able to actually see exoplanets, and it does that by blocking out light from the host star and looking at these directly. But one of the things they even have on the website here is this image. This is the kind of things it can do. This is Titan. So look at that. I mean, that's pretty good for a ground-based instrument. That's Titan right there. So Sphere is a very sensitive instrument, and they used it to image Betelgeuse, and so they came out with this. So here we have the two images, and you can see the definite difference in brightness there of the two. So the next obvious question is, what is it? What could be causing that dimming? Now, as I've told you, that we've been looking at Betelgeuse pretty accurately since the 1930s. And it has undergone other dimming cycles. Stars have solar cycles, or stellar cycles, I should say, just like the sun does. And we're only just now having instruments good enough to be able to detect some of these variations in brightness. But now, obviously, with the ones that are over on the Very Large Telescope in Chile, we're able to get really good instruments, or really good images. So what could be the cause? I knew I'd do that. What could be the cause of that? That right there, that dimming. Well, to really get a better handle on this, let's take a look at something that an image from an instrument called Visier. Visier is an infrared instrument. It's designed to look at gas and dust that is cool. Stuff, not cool as in, okay, never mind. Just temperature-wise, cool. And this is what it's designed, and this is what it saw. It sees this is not a star-looking image because it's not a star. What you're looking at there is the dust glowing and gas that's glowing from the star in infrared. So that's a lot of stuff in between us and the star. And so there are two basic ideas that they're working with here. They're working on. It could be that the dimming is due to the cooling of the surface. That's due to a lot of stellar activity. This is stuff I was telling you about. That stars go through. They have activity cycles. The sun has a solar cycle with sunspots and high magnetic activity. Then it goes into lower magnetic activity. There's nothing to prevent a star like Betelgeuse from going through something similar, but it would need a magnetic field that's driven by a magneto, kind of like the convection zone of the sun that we have. And I don't know that it has that, but they are doing this new science called or stellar seismology, which is incredible to think about. This is like looking for starquakes and looking at activity within the star itself. And they're getting good enough where they can do that now. But I don't know off the top of my head if that's something we know about Betelgeuse right now. But it could be that the star is just dimming due to stellar activity, some cycle we're not sure of, or it could be that there's been some dust ejection towards us. And this Visier image right here it backs up that second hypothesis, that there's dust in the way between us and Betelgeuse. So that's what's been going on. And if I look at this, one of the things I like to do is read to people some of the quotes from the press release. This was, by the way, done by a group of people, again, like the European Southern Observatory, when Emily Cannon, a PhD student, says that the phrase that we are all made of stardust is one we hear a lot in popular astronomy. But where exactly does this dust come from? Over their lifetimes, red supergiants like Betelgeuse create and eject vast amounts of material even before they explode as supernovae. Modern technology has enabled us to study these objects hundreds of light years away in unprecedented detail, giving us the opportunity to unravel the mystery of what triggers their mass loss. So, I want to look at some of these images because some of the ones they put out here are pretty cool. So let's take a look at this one. This is an artist rendering of a plume that's coming from Betelgeuse. And there's the star itself with, I guess, the gas cloud. The caption wasn't very specific about what exactly this was. It just says a stellar plume, and it's zoomable. So let me zoom it in a bit more. So here you can see the gas, or I guess this is the gas surrounding Betelgeuse. And here off to the right is the scale. There's our solar system to scale. And if Betelgeuse were our star, we would be inside it right now. That's how large it is. In fact, it would go out pretty much all the way to Jupiter and touch Jupiter with its outer edges. But these plumes are going way out past Uranus and towards the orbit of Neptune. So we're looking at 7 Betelgeuse radii, which is about 30 astronomical units. That's 30 times the distance between the Earth and the Sun. So the scale of this thing is just enormous, okay? So I want to show another thing that I found on the intertubes. And this is I'm showing you on YouTube because I want to give credit to whoever it was that posted the video. This is posted on a channel called Rumble Viral, and I did not make this, so I don't want to. But it will show what this would look like when Betelgeuse does blow into a supernova. So here's Orion, the constellation. Orion getting up. We're pretty much where you could see it about this time of night, and here is what it would look like. This would be a supernova that rivaled the one in 1054 that created the Crab Nebula, and it's visible even now with telescopes. But this was visible in the year 1054 during the day, and this will also be visible during the day. What I like about this video is it kind of puts it in various contexts around the world, so you can sort of see, how bright this is. Here's daytime, I think, from New York, and so it would look like another sun in the sky. And it would stay this bright for, I think, months or years. Depending on a lot of the particulars. But I mean, this is saying weeks or months. But it depends a lot on the thing. So anyway, this is if Betelgeuse does go, what it will look like to us. Okay. So is it going to blow? Well, yes, it is going to blow, and it's toward the end of its age. It's toward the end of its life, but it's a lot like predicting volcano eruptions, right? I mean, you've been hearing for years about this super volcano in Wyoming. We hear about volcanoes all over the world. They're active. Mauna Loa is an active volcano. I used to work up there, and we always had to park our cars and drive up there every time up the Saddle Road. We had to be careful, because any day there could be an eruption. So we had to have an egress method of getting away as quickly as we could before lava blocked roads and things like that. So, but predicting an exact moment when that's going to occur is impossible, because we just don't know enough yet about how to forecast things like volcanoes. Because of the life cycle, geologic timescales of volcanic eruptions and geologic tectonic plate movements, all the things that make the Earth active on its crust, these timescales are very, very long. But and it's hard to pick out anything to within, say, plus or minus 5 days or plus or minus 5 years even. So it's a hard science to do. It's the same with stellar supernovae. They do go up, but supernova. This star has been around for millions of years. So when will it go? Well, anytime. But any time to a star could be 100,000 years. So I don't think any of the astronomers I've talked to are not holding their breath on this. It certainly went within our lifetime, but it is on the cusp of this. Well, it should be going, and already we are seeing increased activity. We're seeing this dimming that could be either activity or it could be ejections of gas. Either way, that is an activity that is showing signs of change within the star. So that's definitely an indicator that it's going towards its last stages. And so another big question is, will it hurt us? Well, you saw from that video that it's just going to get bright, and we'll see it, and it'll be beautiful for months at least. But I don't think we have to worry about any danger to the Earth's magnetic fields or any of that kind of stuff. So Fernando, I demand recent radio images of this star now. Hey, I wonder if Alma has taken anything. That's a great suggestion. Let me go look. Alma, Betelgeuse. Alma is the large. Oh, look at this. Alma captured. Oh, this is back in 2017. This is a picture. This is a picture of Betelgeuse captured by Alma, but this is back in 2017. Look at that. I mean, that's a radio picture of the star. And so Betelgeuse is one of the largest. Yeah, we know all that. 1,400 times larger than the Sun. It's been observed many other wavelengths, particularly visible in infrared and ultraviolet. And this is using ESA's VLT. Astronomers are able to see this. Huh. So that is that's Betelgeuse Kepler. But I want to see if there's something newer. These are all from. Oh, this is the Betelgeuse before. I meant to show you this. This is. I tried to load this video on my streamer, but I didn't. I had problems. So here's an animation of the difference between the two. So you could see that is pretty significant, 34 or so percent. So there it is now. There it was back a year ago. And again, back to now. So, Victor Del Mastro, will neutrino detectors pick up a signal just before Betelgeuse goes? Yes, well, I mean that's the idea, right? There should be a neutrino flux coming beforehand. So I think so. So yes, it should be. We should see a neutrino increase in flux coming from that area right before it blows. So yeah. I'm sorry. I wish there was better radio images of Betelgeuse. Let me just be more specific in the search. Let me go radio images Betelgeuse. You guys are watching Tony surf the web. Betelgeuse. Radio images Betelgeuse dimming. Let's see what Google says. Oh, here we go. No, this is CNN. Space.com. I'm not going there because I'm sick of pop-ups. Will the bright star finally explode? Space.com again. Now, I'm not seeing radio images. Alma should look at this, though. Alma should definitely look at this because Alma is the highest resolution radio telescope we have. It is an array of radio telescopes, and again, in Chile. And it's looking at the sub-millimeter bands. That's part of its name. Millimeter, sub-millimeter array. And it is one of the most amazing. It's what helped get the Event Horizon image of the black hole last year. Remember that? We saw that with data taken from ALMA and other places as well. But ALMA was a huge contributor to that. So that was pretty cool. But so ALMA should be looking at this. I don't see anything from ALMA though. So that's a good one. That's a good idea. Okay, let me read a couple comments, and then let me see if nobody's in the public voice channel. If you guys want to chat, by all means, bring me some chattage, and I will put you, and I will listen to you, and you can spam us all with your thoughts. No, I'm sure they're not spam. Let's see. Fernando again. Do we have any recent pictures of this star in other wavelengths? Might be useful to compare radio astronomy pics from before and now to see if there's a dimming too. Well, it is looked at a lot in infrared and visible, as you just saw, there was two of those images, Vizier and Sphere. Took those two images of Betelgeuse. The only way to see it in ultraviolet right now is Hubble. And Hubble is not looked at Betelgeuse as far as I can tell. In fact, Hubble is the only game in town for extreme ultraviolet images. You have to be in space to take those images because the atmosphere blocks UV radiation, or at least a lot of it, so that we can live. I don't know if it's dimmed in the UV, but would you expect it to? Let's think about this for a second. If it is dimming by gas, which is what they're saying, one of the things could be dust ejections from the surface, then you would expect it to block the UV radiation. So there would be a significant dimming in UV if there is dust in there. If it's just solar activity, if it's just stellar activity, but not an ejection of dust, then you might actually see a brightening in UV. So that would be an important observation to make. And I don't know if anyone has made it. Oh, that was a faux pas. Sorry about that. I always forget to put my phone on Do Not Disturb. So what am I? EUV, Betelgeuse Beetlejuice. How many of you spell Beetlejuice? E-U-S-E. I do that every time. Let's see. UV visible spectrum of Beetlejuice. But these are old. Pushes limits of EU. Nope. No, these are all old. So calibrated spectrum of Beetlejuice. Nope. I don't see anything that there's one of Antares from 2010. No, I don't see anything that people are looking at in that regard. So sorry about that. Besides, I would expect the Hubble guys to come out with something on that. So, all right. So let's see. Any more? Let me read a couple more comments. That's a great before and after. Yeah, that was pretty cool that they took that. Again, that was with Sphere. They took that. Orion Constellation is really familiar for people in the southern hemisphere, especially that star because it's red. That's right. And the southern hemisphere is so amazing to catch. It'd be great if everybody could get a chance to go down there and just try and find the constellations. I love my chance when I go down there. I've only been down there a couple of times, but it's really great. And yes, you can see Orion. It's low in the horizon. So let's see. Okay, how many people have said Beetlejuice 3 times today? All right. There's one more thing I want to show you that I thought was, I don't know. It's very indicative of the times we live in. Let me show you this. So ordinarily, all right, let me get rid of this stupid video. So here's a website called Tech Times. Now, I always thought this was kind of a reasonably together website. I mean, at least as far as technology, I've read it before and they didn't hear anything wrong. But look at this headline. Betelgeuse Supernova explosion happens on February 21st. That's tomorrow, Expect darker skies for months. Now, 2 things about this. Both of these are absolutely wrong, and I don't understand it at all. So Jamie P. from Tech Times. Wow. Okay. So this was like last week. This was published. So I saw that, and this has been indicative of a lot of the headlines that we're seeing. And it's probably why a lot of you are here right now to learn about this, what's really going on because of this kind of stuff. So look at this for a second. Supernova explosion might happen soon and visible on Earth skies. So on February 1st, veteran Villanova University astronomer Edwin Guinan released a study about Betelgeuse. True, he did. The supergiant star has 20 times, okay, so we know that 642 light years away. He mentioned in his blog that the supergiant star seemed to be acting weird for the past months as its light gets dimmer and compared with before. I'm not going to critique the writing of this, but though the confirmed information is that the supergiant star has only 100,000 years left before it disappears, the dimmer light coming from Betelgeuse was reportedly unusual. According to the National Geographic on December, if this continues and the Betelgeuse will explode, a glorious sight will be seen on Earth, making the skies darker even when it's morning or daytime. Now, let's just absorb that for a minute. Didn't I just show you that video where we saw what Betelgeuse would look like if it exploded and what it would look like from Earth? Didn't I also explain, oh good, we're going to get spammed with videos, that the 1054 explosion that the Chinese saw and many others around the world, the Anasazi Indians, saw it during the day and recorded it for a long time. So how was that going to make the sky darker? That's what I want to know. So if we can get away from all of this ad crap, sorry about the video, but I really want to highlight this webpage for a minute. And this is also very telling that we have to deal with this. But okay, so making the skies darker even when it's morning or daytime. The very next sentence, when this star detonates, the explosion will be bright enough to cast shadows on Earth at night and will be visible during the day for a few months at least. Then the star will fade from our sky. 2 contradictory statements right in a row. And finally, this one. The tentative date that Betelgeuse will be dimmest, or meaning it will explode, will be on Friday, February 21st. I'm amazed it didn't tell us what time, but it's tomorrow. Okay, it's going to go. No need to wait for an update from NASA, since everyone is expected to see this spectacular sight from Earth's skies. So, there you go, tomorrow. I haven't read this nowhere else. So, though it is clear that the Earth will be safe once Betelgeuse might explode in the sky, few science experts claim that there are no chances that the supernova explosion will happen to Betelgeuse anytime soon. Few experts claim there will be no chances that if you understand this, great. Now, Tony Phillips, I know him, of spaceweather.com, mentioned that the said explosion is not going to happen since the dimming lights of Betelgeuse were actually not unusual for the supergiant star. So I'm getting the feeling that a lot of copy and pasting is going on here in this article. It must be said, however, that predicting supernovae is not a very exact science. So there's still a possibility, however remote, that Betelgeuse's fiery end could indeed happen tomorrow. Or to be more exact, it happened 642 years ago, and the light from it is about to reach Earth. Whether or not it's real, once you see the skies getting dimmer, you'd better take a picture of it. So I hope you guys, this is from Tech Times. This is probably the worst one I've seen. Betelgeuse supernova explosion happens on February 21st, tomorrow. Expect darker skies for months. And then we get brighter skies because it casts shadows. So which is it? So let me just delete that tab. I just wanted to show you that because that was insane. So if you've been reading a lot of stuff about this, please try and read it critically. Okay. When I read an article, I try to read it for what, the context in which they're trying to say it. That was clickbait of a major order. But if you're reading this stuff and you don't feel comfortable enough to question this yourself, and you're starting to get worried about it, then let me just tell you that you are going to be fine. Okay, there's nothing to worry about, and it's not going to happen tomorrow. If it happens tomorrow on February 21st, then what should I do? I should do something. I will eat old timers used to say they'll eat their hat, but I don't know. I need to do something else. So, Anthroparian. Let me just check my Mayan calendar. That's awesome. That's an awesome comment. I love it. It was written by the Tech Times webbot. It did read like that, didn't it, Capital? I mean, it's like, what the hell? I mean, I was like, it's just copying and pasting stuff from other things. I guess their brain exploded before Betelgeuse. Very true. Dan, hi, it's good to see you again. Maybe their site was hacked and someone decided to put up some fake news. It's possible, yeah. Well, if it does explode, you'll have to apologize to him. Yes, like I said, I should do something if it does explode tomorrow. I'm responding to a flat earther. Oh, was he a flat earther? Okay. Well, see, it shows what I know. But I picked that article because of its ridiculousness. So I guess I'm not surprised. So thanks, Larry. I didn't know he was a flat earther. What kind of corpse will Betelgeuse leave behind? Good question, Princess. Okay, so what's going to happen after it blows up? Well, it depends on what happens to a star in when it dies. Depends on its mass. And as we've talked about, this is many times more massive, about 60 times more massive than the sun. And so a star that massive, and I think it's greater than 20 solar masses. If a star is greater than 20 or so solar masses, then when it runs out of its nuclear fuel, it will start the pressure that was keeping the star shining. Change shots. The pressure of the star that was being held up by the fusion is now starting to get overcome by gravity. That further compresses the things, heat things up, and then other elements fuse for a while, depending on how much there is. When we did the Wikipedia page on this, the metallicity of this star was very low, meaning it was mostly hydrogen. And so these stars will compress even further after the hydrogen's gone. Then it'll start to fuse helium and then keeps fusing heavier elements, carbon and oxygen, and all of these other elements until all of this stuff gets spent relatively quickly, and the pressure from nuclear processes is no longer enough to overcome the gravitational pressure, and the star collapses. One of two things can happen depending on the mass of the star. I think Betelgeuse is kind of at the mass range where one could expect it will expand rapidly, explode, okay, in a supernova explosion, leaving behind the inner core of either a neutron star, which is a star that is where the material has been compacted so much that the neutrons are basically touching. It's called neutron degeneracy, and it is shining. Okay, it is a very dense core left behind. Neutron stars are roughly, I think, the size of the Earth and smaller. Or that collapse will not be stopped by neutron degeneracy, and it will keep on collapsing into a singularity, which is a black hole. And what will be left behind then will be a point beyond which nothing can get out. It'll be a stellar-sized black hole, measured in the masses of the effect it has, the gravitational effect it has on its surroundings. I don't think it'll be a 60 solar mass black hole, because a lot of the material will already have left in the supernova. What happened in 1054 with the star that exploded then and made the Crab Nebula was it created a neutron star in the center. Now, when a neutron star spins very rapidly, it also pulses along its poles, spin axis, and you can detect those radio waves as very fast, high-frequency pulses, and they're called pulsars. And that's the Crab Nebula. The Crab Nebula is a supernova remnant, and if you look at it through a telescope, it's in the constellation Taurus, and it looks like this. Crab Nebula. Look at Wikipedia so that I don't violate copyrights. Here we go. So there's the Crab Nebula. And here's one from NASA as well. This is what it will look like, essentially. I don't know off the top of my head the size of the star that created this. They figured it out, I'm sure, but I don't know what it is. But that's what the Crab Nebula looks like, and that's what Betelgeuse is going to do. So that'll be cool. So good question, man. Thanks for that. Let's see. I'm not responding, by the way, Larry Keys. I was ridiculing. If the Gitmo Holiday says, if the cause was ejecting gas, you would expect other objects from the same direction behind Betelgeuse would be less bright also. You mean like a star that is in the same field of view but behind it? That's true. You should see a dimming there as well. But no, you're right. You should, because if it's just stellar activity, it's just the activity on the surface of Betelgeuse that's the reason for this dimming, then you're right. You would not see dimming in things behind it. But the problem is Betelgeuse is really, really bright. And if we look at this Vizier image again, let me put this up. If we look at this Vizier image again, excuse me, there we are. Then we can see that this doesn't extend too. This doesn't really tell us our field of view here, but anything that would be bright in the infrared would need to show up here as well, and you don't see that in here. But that's because this image, this object is so bright. But you do have a point. If there is anything behind this, then we should see it. If it's not dust, or if it is dust, we should see it dimming also. Invite him on the show. I'm not inviting that guy on the show. Let's see. John Suffel. The slight increase in brightness seen in the past few days would be expected once gas blown off by the star thins out. That's true. And they're expecting now for Betelgeuse to level off. In fact, its brightness appears to have done that. So whatever has been happening in the past has appeared to stabilize, and now we're left at kind of a kind of a plateau, I guess, of its brightness. So it's not changing anymore. Let's see. Sol tubes. Neutrino emissions will be emitted like moments before it blows apart, if I remember correctly, from star documentaries, and won't be visible until 700 years later. So the only option is computational prediction. Well, okay, but yes, before we see anything, we will see a neutrino flux increase. I don't know if Tony has mentioned, but the telescope run by ESA saw a huge amount of gas that has been blown off by Betelgeuse, causing the recent dimming. Yeah, we talked about that, and I think it was ESA, by the way. I don't know if ESA has seen it. Princess, how do we get magnetars out of neutron stars? Well, I think they're just rapidly spinning. Well, magnetars. What is it? I don't know what a magnet. Let me look up magnetar because I'm going to make sure I answer this right. Magnetar. Aren't you glad that you can watch me just sort of? A magnetar is a type of neutron star believed to have an extremely powerful magnetic field. The magnetic field decay powers the emission of high energy electromagnetic radiation, particularly X-rays and gamma rays. So it's just the same thing. It's just a highly magnetic neutron star. Raj, I don't know how many planets are in orbit around Betelgeuse, if any. I don't think any are. So I'm trying to think. The transit method is, I think we've looked at that area of the sky a great many times with, I guess Tess would have been the one that's seen it. I don't think anybody has seen any planets around Betelgeuse yet. So I think that's it. Hey, Saul. Hey, well, listen, man, this is, I'm here with you guys. This is my chance to, interact. We don't have guests. And so I just want to talk with you guys. So, I want you guys to get a chance to interact about this topic as well. So let's see. At some point in the distant future, we'll run out of stars, and eventually, this is from R. Walton, and eventually even protons will decay. There will be basically nothing left in the universe. That's right. It's called the heat death of the universe. And it's going to be very depressing. But the good news is that's hundreds of trillions of years from now. So it's going to be a long, long time. Even black holes will evaporate. So, yeah, Hans, I just answered that. I don't know. I don't think there are any planets around Betelgeuse. Exoplanets around Betelgeuse. Notice how I'm just using Google. That's my authority on everything. So here's an answer from. Get rid of this. Boop. Does Betelgeuse have any? So let's see. Betelgeuse is kind of a mess. This is from a guy named Clifford Poyner on Quora. It's in the geriatric state of its existence. That's a good point. It is an old star. This was taken by ALMA. It's the brightest resolution picture. They can actually see the surface of the star. The bulges may be solar flares or prominences. I don't think there's any planets around it. You get a lot of things not... Oh, here, let's see what space.com. No, that's from ALMA. Let's see. Are there any planets around Betelgeuse? Quora says there's unlikely there is any. That's a good point. So planet formation takes about 1 to 10 million years. Given that Betelgeuse is only about 12 million years old, remember, this is a supergiant stars, both of the red and the blue variety, don't live very long. And it takes a while for planetary systems to form. Earth was pretty much ready to host life about 3.5 billion years ago, so it gave it about 1 billion years or so to make the planets in a condition where something can happen. When you go from making a star to protoplanetary disks to debris disks, and then you have these condensing planets from the surrounding material, that I guess it takes a little bit longer than just 12 million years, which is how long Betelgeuse has been around. So I think the consensus is no. It has no planets. But I'm saying this having just looked at Google for looking at what this is about. So take that with whatever it's worth. Let's see. So I think let me read some more comments here. Giveaway. What are we actually learned from this happening from the star, and how will it help in knowing the sun? Well, okay, that's a fair question, giveaway. So we've known for quite a while the stellar life cycles of the different kinds of stars, right? The life cycle of a star is wildly different depending on its mass. Okay, that's the big factor that changes here. So if we've got a sun-like star, which is sort of a yellow dwarfish kind of star, burns for roughly 10 billion years. It does not burn as hot nor as fast as supergiant stars like Betelgeuse, or super blue supergiant stars like Rigel. So they don't last very long. And so what we can learn here is we can, first of all, test a lot of our stellar evolution theories. People have a lot of ideas about what stars go through, and to see stars in different stages of their life is really kind of cool. Betelgeuse happens to be at the end of its life. So we can see what these large stars do at the end of their time. So that's the big thing that this will teach us, is what are late cycle stars like that are this big. Another interesting group of stars are red dwarfs. They are the other end of the spectrum. They are barely stars in some cases. Brown dwarfs, red dwarfs, that whole side of the star size spectrum. These things are smaller than the sun, way dimmer, and they will burn for not billions of years, but trillions of years. A red giant star has yet to die in the universe. I mean, a red dwarf star has yet to die in the universe. So there hasn't been any. And when they die, what will they do? Well, I made a video on this, so you can check out the Embers of Creation. They're called red dwarfs. So you should do a search on this channel for that video that I made. But the first one won't die for a very, very, very long time. The universe isn't old enough to have seen a red dwarf star die. So that's what it can teach us. Red giant stars burn fast. Yes, they do. ASCII. Will it go? So Mark Namer, will Betelgeuse go nova in our lifetime? It will go supernova. It won't go nova. Nova is a situation where you've got a white dwarf orbiting a star, and it's sucking material off of that companion star until enough material builds up that it flares into a new star, and that's called a nova. And it's not an explosion like a supernova would be from these stars. And will it go in our lifetime? Well, that's what we've been talking about. It's like predicting a volcano. Will Mauna Loa or will Haleakala on Hawaii or any of these other active volcanoes, those are the two I can think of off the top of my head because I've been to them, will they erupt in the next 5 months? It's impossible to know. We don't know. We can't predict things to that level of precision. And the same is true here. Will it go in our lifetime? Maybe, is all anybody can say. It's like the supervolcano in Wyoming. There's supposedly a subterranean volcano underneath the Earth's crust in Wyoming area of the United States. And when the thing is supposed to be huge, it's a supervolcano. And it shows activity, people, rumblings and things like that go on. And stupidly, we also frack the area with for oil, making things even more unstable. But it extends all the way past Wyoming into Oklahoma and the Dakotas and this whole area of the United States. When will it go? Will it go? And even harder question to answer is, will it go by a certain time? That's a very difficult thing to know or to predict because we don't have the science for it yet. So let's see. Will Yellowstone erupt in a few months? Yeah, exactly. It's like trying to answer that. So what is a hypernova? Asjad wants to know. Well, I made a video on that too. The VY Canis Majoris video. You should check that out. But hypernovas are extremely massive stars that make Betelgeuse look like a baby when they go. And they will they're impressive events. I don't know when stars like VY Canis Majoris will blow. Again, it's the same kind of thing, but it is. Even though I made the video on it, it was years ago, and I forgot the details of when it will go. But anyway, these are the next level of supernovae or stellar explosions. Dan Edwards, the chaotic nature of these systems make prediction not a thing of any certainty. That's right. And we also don't know enough about what the actual force is going on. Getting back to volcanoes, we know that the Earth's crust is very active, and we can predict and we can plot and we can measure where the plates are moving and where the fault lines are, but we can also measure stresses. But what we can't ever really detect, I mean, people have been waiting for a big one in Los Angeles now for at least, I think the last big one was it Woodland Hills or no, Sherman Oaks? I forget. There was a big one in the 90s that did a lot of damage in, I think it was Sherman Oaks. You guys that live out there would know. And in the 1990s was the last really kind of big earthquake California's had. And everybody's kind of like moved to California without having ever really experienced an earthquake there. It's kind of a quiet period. But everybody knows that it's not done yet. There's going to be stresses along these various fault lines that the Los Angeles basin sits on that are going to go. And we can measure those stresses, but what we can't predict is, okay, you've got two plates pushing against each other harder and harder and harder. Well, boom, when can you predict that is going to give, right? That's really hard to do, and especially at any given length of time. And the same is true with the supernovae explosions. I use that as an example because geology happens on really long time scales compared to us. And so we can predict much better whether a thunderstorm or a cold front is going to come through and when and what its effects will be with much greater precision than we can anything that happens on these really long time scales like geology or astronomy, stellar time scales. So, all right. So that's a good question. Barnard star. Seems I heard something about that. Barnard star is one of the first stars we ever measured a wobble in. Barnard's star. When exoplanets or things in orbit around a star pull on that star, then you can measure a wobble in the velocity in the spectrum. The spectral lines of that star will move back and forth, and how much it moves back and forth tells you something about the thing that's pulling that star around. So Barnard star is a red dwarf about 6 light years away from the sun in the constellation of Ficus. It is the fourth nearest known individual star to the sun after 3 components of Alpha Centauri system. So it's very close to us. And it's the closest star in the northern celestial hemisphere. So Alpha Centauri, Proxima Centauri, all those are in the southern hemisphere, viewed from there. It's a tiny star. It's only about 14% the mass of the sun, and it has a very bright magnitude, actually, of about 9.5, which is pretty bright for something so small. So that's pretty cool. It's named after astronomer E.E. Barnard, and he was not the first to observe the star, but he was named after him. He got the first right with the proper motion. It's one of the most studied red dwarfs because of its closeness and favorable location for observation near the celestial equator. Many people argued that there were one or more gas giant planets in orbit around it. The specific claims of large gas giant planets were refuted in the mid-70s after much debate. In November 2018, a candidate super-Earth planetary companion known as Barnard Star B was reported to orbit Barnard Star. It is believed to have a minimum of 3.2 times the mass of the Earth, and it's in orbit around half an AU or so. So it's very close to it. So again, remember I told you that wobble tells you something about what's in orbit around it, and a lot of times back in the 60s and 70s they thought it was a gas giant, but they've come along and found that it's a super Earth. They say it's a candidate super Earth, but they don't say who measured it, or what measured it, whether it was Kepler. I don't think it was Kepler. Kepler wasn't looking in that part of the sky. Kepler was looking in the constellation of Cygnus, and Ophiuchus isn't by that. So yeah, I don't think it. So yeah, there's one companion around it, Barnard star B, with all the characteristics I just told you about. It goes around the sun. It goes around that star once every 232 days. That's its orbit. So there you go. That's about Barnard star. Look up Pickett's Bell, posted on Cloudy Nights as far back as 2016. What is this? Oh, Beetlejuice's ring. All right, here you go. So here is Cloudy Nights. Is this what you're talking about? That I don't know if it's coming through on the stream, but there is a ring around this right here. And this is a sketch. It's not a photograph. I don't know anything about this other than what I just saw. This is a sketch, and it shows that. Seeing it in binoculars. Yeah, I don't know much about this. Sorry, I wish I could comment more on it, but everybody's commenting and yeah, so okay, well, what do you want to add something to it when they because I don't know much about it, so I just showed it what I know on Cloudy Nights. When they give a letter or letters in ascending order to a planet, why does it start from B and not A? I asked that to a guest on a hangout a while back when we talked about, well, we've had tons of exoplanet hangouts, and the answer is that the star is considered capital A. The stars are capitals and the exoplanets are lowercase. And so if you've got a binary star system, you have star capital A and star capital B is the binary star. If there are any planets in orbit, they all have little letters around them starting with B. And the answer is no reason. And you'll find that with a lot of stellar classifications too. That, for some reason, and I don't remember the specifics, but population 2 and 3 and 4 stars, there's no progressive sense made to those categorizations. So a lot of this stuff comes out organically, and I think it's because they don't want to confuse the main star, which is classified as A, with all these others, but no one really knows, to be honest. I don't know, and the guy I asked didn't know. Yeah, I was talking about Pickett's Bell there, James, and I don't know anything about it. If you guys want to enlighten us, go ahead. Yeah, thanks for subscribing, guys. I do appreciate it, and I think we're running out of time. So if you got any other questions, also feel free to use Super Chat, guys. It's okay. So Aloha Milton. Fracking is not doing much to a magma chamber. Think damage from activated near the surface faults causing insurance issues. Damage to pipes and plumbing being the biggest cost. Well, okay. But, I can't imagine that when you are weakening a crust with water, putting it under pressure, enough that it's causing hundreds of minor earthquakes a year, as is the case of Oklahoma, for example. The number of earthquakes recorded in Oklahoma went from a few dozen to over 500 in a given year because of fracking. You can't tell me that doesn't have some effect on the underlying mantle. Okay, maybe not, but if you're gonna crack it with crusty stuff, crack the crusty stuff above the molten stuff below. I don't know. Doesn't seem smart, especially if there's a super volcano nearby. But that's just me. Okay. Not a fan of fracking. Sorry. They tried to do it here in Florida. I think it's a bad idea, and it's a waste. So that's also my bias. Take that with whatever you want with it. So, Cliff, I answered what will it leave behind? A new lasting gas cloud like the Orion, or will it just disappear after some time? So, Cliff, what it will leave behind is a nebula, much like the Crab Nebula. And the core will either be a neutron star or a black hole, depending on the particulars of the collapse, okay? And the exact masses involved. It's not an exact science where things are, if your things are above 60 solar masses, it turns into a black hole. Less than that, it turns into a neutron star. There's a lot of other factors that go into play here, but by and large, it will either will leave behind a beautiful nebula for sure, and either a black hole or a neutron star when the core collapses. So that's the core will either collapse and then stop with the neutron pressure, or the neutrons won't be strong enough to hold it up, and boom, it'll go all the way down to a black hole. So, wow, this was really cool. A lot of you guys had some great comments. Let's see, one more. Aloha, Milton. You're into. Okay, so I see I'm getting into your bailiwick there. You're really into oil and gas. So oil industry dumping costs others unfair, but not going to cause a supervolcano magma chamber much concern. Okay, all right. Well, I'll concede that point. Still, I've said my piece on that. It doesn't seem like a smart idea. But then he left to go fishing. So I hope you get. So I hope you get some fish, Aloha. He's probably in Hawaii, which he knows a lot about volcanoes because they're part of life out there. Jane, how many stars plus light years away can we know if we are not looking at the past? Well, that's just the thing, Jane. No matter what we do and look up in the sky, we're never looking at the present. We can never see what's going on right now, this minute at Betelgeuse. Can't know. We can't even do that with our own sun. We can't look at the sun and know what's like right now. Everything we're seeing is 8 minutes old, right? So there's no way to know on most things we look up in the night sky, unless it's clouds, that we can see things as they are today. It's just a speed of light thing. Light has to travel. It takes time to get to us. So what's the edge of the universe doing right now? Don't know. We won't know for another 13 or so billion years, because that's how the observable universe radius is right now. So it's going to take a long time to see these things. Now, the actual size of the universe, this is going to blow your mind, is more like 96 billion light years across. So figure out that. How did a 13 billion year old universe get 96 billion light years across? How did that happen? If the speed of light is what it is, right? Well, it turns out, I'll just give you the answer. The speed of the expansion rate of the universe is not bound by the speed of light. That the rate at which the universe is expanding is not a speed of light limited thing. So it was, and there was this thing called inflation. We talked about that. Was it last week or the week before? I think it was last week. So watch last week's hangout with Brian Keating as well, and you'll get more information on that and how that could have happened. Okay, guys. Well, I'm gonna go. Somebody's blowing up my phone like I'm forgetting something, so I better head out of here. Next week, don't forget EV-Scope, guys, Unistellar, Telescope Talk Hangout. I also do Tony's Twitch Tuesday on, guess what day? Tuesday, guess where? On Twitch, same time, 3 o'clock. We call it T-Cubed. I don't do anything but just ramble and talk with you guys. But next time, remember, use the Discord channel on the voice channel on my Discord server, and I'll patch you into the Hangout. We can talk together. Watch Tony's Twitch Tuesdays on Tuesday. Next week we've got Telescope Talk Hangout, EV-Scope, and also do all the following and the stuff. And thank you guys for watching. I just posted a video on Apophis about a week ago. Hope you guys will check that out. Susan, thank you, man. Thank you for the help. I do appreciate it. This stuff really is becoming important because it's hard. It's hard to pay for this stuff. So thank you, Susan, very much for the support. Okay, guys, I'm going to end the stream. Thank you all so much for watching. And as always, keep looking up.